Hi, I'm Darian. I have with me David, Ishan, Reed, and Quinton. We are members of Shockwave, FRC Team 4488, and we are very proud to be here representing our team. To start our presentation, we would like to show you the animation of our game, Chain Reaction.
Team 4488 Shockwave proudly presents this year's game, Chain Reaction. Chain Reaction celebrates scientists who show the perseverance and ingenuity to solve the world's biggest challenges. In Chain Reaction, a natural disaster in First City has caused the release of a dangerous toxic hazard. Two alliances of 3 robots work frantically in the first chemistry lab, collecting and analyzing chemicals to create a cure and save the citizens of First City. At the start of the match, robots autonomously jump into action to prepare the research materials. Robots may be preloaded with up to 1 chemical of each color. During the 15-second autonomous period, robots may earn points by driving off the initiation line. Additionally, the normal scoring options have an increased point value prior to the drivers taking control. Throughout the match, chemicals may be scored in the lower and upper beaker openings, matching the color of the chemical to the color of the beaker. If the colors do not match, fewer points will be awarded. Additionally, robots may score chemicals into the crucible. Reactions can be created by combining sequences of chemicals in the mixer and activating with the mixer chain. A reaction with 3 chemicals of the same color increases the potency of the corresponding beaker. Every chemical correctly scored in that beaker during a match is awarded an extra point per potency level. A reaction with 1 chemical of each color in the mixer delivers 9 additional chemicals to the field through the barrette. Chemicals can also be introduced by the human player from the cabinet in the repeating pattern red, white, blue. At the end of the match, robots rush to the decontamination zone. Robots can score by parking in the lower decontamination zone, hanging from the distribution chain, or climbing the chain and landing on the upper decontamination zone. Pulling the distribution chain releases the cure and saves the day.
The video gives a good overview of the game and several of the terms we will use during the presentation. We'd like to go over our game design process, details about our field elements, robot actions, our game scoring table, and a quick view of the game analysis performed by the team. Our game design process began in the preseason, where we dedicated ourselves to learning how to design FRC games, reviewed previous games, exercised the design process using a given theme or mechanic, and established evaluation and scoring metrics for our game ideas. Once the official challenge started, the team broke into groups and created various general game concepts. In this slide, you can see some of them. The goal was to get everyone involved and figure out potential themes and game mechanics that our team wanted to develop further.
To narrow down all of our ideas, we formed the criteria of a good game. We wanted the game to be enjoyable for everyone, so we broke it into 4 groups. Builders, the people making the robots, players, the drive teams, audience, and field personnel. We designed our game with each group in mind, featuring simple at-home field construction, a practical competition field with feasible live scoring, fast field reset, and proper safety measures. This all makes chain reaction fun and realistic. The chain element is present in chain reaction as various interactive elements. In the endgame, robots use the distribution chains to climb up and onto the upper decontamination zone. Chains at the top of the beakers deflect chemicals into the upper opening. Finally, the mixer chain is pulled to release chemicals in the mixer, triggering events in the beakers or barrette, what we call activation. Note that spheres are located at the bottom of the distribution and mixer chains to simplify the interaction between robot and chain.
Here's a closer look at some special considerations we made when designing our field elements. We made the chain height constant relative to the floor. The opening to the cabinet, which is our human player station, matches the height of the opening of the mixer and the side opening of the beaker. The inside of the beaker has a helix structure to prevent chemicals from jamming in its entrance. Decontamination zones are wide enough for all robots in an alliance to have the opportunity to climb, and the chains and adjacent posts are spaced out to encourage buddy climbs. All these details were incorporated into the game to satisfy our design criteria. We offset the beakers to open up robot avenues to cross the field and prevent defensive choke points. This also opened up the beakers to be scored into from all sides. Even the alignment and design of the beakers allow for both drivers and spectators to see each beaker more clearly.
That brings us to the mixer activation. If 3 chemicals are placed in the beaker and the mixer chain is pulled, then the mixer is activated. If the chemicals are all of the same color, then the beaker potency increases. If the chemicals are one of each color, then it'll activate the roulette, adding more chemicals to the field. This adds an extra layer of strategy. Should teams prioritize putting chemicals in the beakers, or do teams use the mixer to enhance the value of existing chemicals in the beaker? This is a scoring table for chain reaction. Based on detailed cycle analysis, we came up with points per action to make the game more balanced and eliminate big jumps in the score. Also, compared to previous FRC games, our scoring offers more ranking points, and all types of robots can earn these points, even robots that don't shoot chemicals. But that's not to say these ranking points are easy to get. They're still challenging. This decreases the component of luck and qualification rankings and rewards ranking points based on strategy and skill.
To refine and balance our game, we applied our standard game analysis process that we've used in previous FRC games. On this slide, we have one example of our multiple simulations of different alliance roles. The robot parameters drive the values in the other table, where cycles and points are calculated. Estimating the time and difficulty of robot actions allowed us to make sure that no one aspect of the game overpowered another. To finish our presentation, we would like to emphasize some unique features of chain reaction, such as the beakers allow for scoring from all sides, multicolored chemicals promote sorting by color, mixer activation provides different strategic outcomes, and climbing a chain in order to reach a platform. In summary, we believe we have created a very exciting FRC game, which has all the components to be super fun for teams and spectators alike. Thank you for your attention.